Alright, so this is question 6 from 2012 HSC Trial 2 unit for William Clark College. We got Brendan planting a wattle tree at 70 centimetres tall, and then at the end of the first year of growth it reaches to 120 centimetres. So that means during the first year we've got 50 centimetres growth. Now the question then tells us that each year's growth was 90% of the previous year, and so you can see by that instantly they're setting it up as a geometric progression in terms of the growth. So the growth is a progression. So the first year's growth is going to be 50 centimetres, then the second year's growth is going to be 50 times 0.9, because that's 90%, and then because it's 90% of the previous year, the successive year will again be, so year 2 it grows 50 times 0.9, but year 3 it actually grows 50 times 0.9 times 0.9 again, and so the successive ratio each time is 0.9, and we've got a geometric progression going on there. So remember, each term is growth. So the maximum height of the wattle tree, well, that's essentially because it's a limiting sum. You've got A being 50, you've got R being 0.9, and when it says what is the maximum height of the wattle tree, what it's actually asking for is a limiting sum. So S infinity, which is equal to A over 1 minus R, is equal to 50 over 1 minus 0.9. Okay, now that, remember, is the growth, and the problem is that we started with an initial plant height, so the answer to the limiting sum is not going to be the answer to the question, it's going to be the answer to how much growth has occurred. So we'll do S infinity, and we'll find out that we've got 50 divided by 0.1, which is just 500. So that's 500 centimetres of growth, plus you have an initial plant height. So 500 centimetres total growth, and that means that the maximum height of the wattle tree is going to be 500 plus 70 equals 570 centimetres maximum height, which is answer C in that question. Okay, so the next question is question 10, which asks how many solutions are there to 2 minus x equals 4 cos x. Now essentially this is asking us for not what the solutions are, but how many there are. And the importance of that is that it's a different way. You're not trying to solve this entire equation. All you're simply trying to do is figure out how many solutions there are. So here's what we need to do. We need to graph them both, and we need to do it actually reasonably accurately to scale. So 4 cosine x starts up at 1. That's quite important, because it then goes down to 0, down to minus 1, and back up to 1, and it's at here at pi on 2, it's at minus 1 at pi, it's back at 0 at 3 pi on 2, and it's back up at 1 at 2 pi. Okay, now the reason that's important is because the y-intercept of 2 minus x, so that's the graph of y equals 4 cos x, right? But the graph of y equals 2 minus x starts up at 2. Now this is not quite going to be to scale, but it comes up there and it's going down like a gradient of -1 because of the negative x there. So that means by the time it gets to 1, which is about here on the graph, it's down at 1. Okay, it also means that when it gets to 0, it gets to 0 at x equals 2, and x equals 2 is down here roughly, so it's roughly there, because remember that pi is roughly equal to 3, and so it will continue going along that gradient in that way. Now, we know that there's no possible other points of intersection other than this one just here. And the reason we know that is because 2 minus x is going to keep going in that direction, and 4 cos x is going to keep oscillating between 1 and minus 1, and therefore there's no other possible place for it to intersect. That means, of course, that there's only one point of intersection on our two graphs, which means there's only one solution between these two things, and that'd be answer B. So one solution. And there's only one solution for the equation because there's only one point of intersection between the two graphs. Alright, the next one along is 12b, which is a trig question, and that trig question asks us for the exact value of cos pi on 4 plus sine 2 pi on 3. Now these are essentially just both getting you to ping the exact value triangles. So remember that the exact value triangles have these two triangles. We've got, that's pi on 3, that's pi on 6 and 90, or pi on 2, and 1, 2 and root 3. And then we've got the 45 degree, or pi on 4, 1, which is 1, 1 and root 2. So cos of pi on 4 is pretty straightforward. You can read that straight out of the exact value triangle, which is just 1 on root 2. That's easy. And then sine 2 pi on 3 is a little more complex because that's getting you to use equivalence. Okay, so 2 pi on 3, if you have trouble with radians, you can turn that back into degrees. 2 pi is 360, and divide that by 3 is 120. So you're looking at 120. Now you need your bow tie rule for that one. So you've got your angles there. So you've got pi on 3, and then you've got 2 pi on 3. And that's not drawn perfectly, obviously, that angle's a bit small. But then the next one round is going to be 4 pi on 3, and then 5 pi on 3 is the fourth one. Okay, if that's confusing you, then just remember the bow tie rule, and sine 2 pi on 3 is definitely in the second quadrant, so sine is going to be positive. Therefore it's going to be equal, so sine 2 pi on 3 is going to be equal to sine pi on 3. And sine pi on 3 is sine 60, and sine 60 is just root 3 on 2. And therefore the answer to the question is actually 1 on root 2 plus root 3 on 2. And if you want to combine that into one equation, or one fraction, you can make that, you can times the left fraction by root 2 on root 2. That gives you root 2 on the top plus root 3, and on the bottom root 2 times root 2 is 2, and so you've got a common denominator. And so the answer is root 2 plus root 3 on 2.